take a survey to know which is the most popular sport in your region. Of course, you cannot ask everyone, so you decide to ask 30 people in your region. You have classified your survey into 4 categories. 3 of the most popular: cricket, football, tennis, and all others under other sports. So the first person you meet says he likes football. So you write a 1 here. The next person says she likes tennis. So you write a 1 next to tennis. The next person says football. So you write a 2 here. We want to count how many people fall into each category. So out of 3 people surveyed, 2 like football and 1 person likes tennis. The next guy says cricket. So you write a 1 here. The next guy also says cricket. So you write a 2 here. So out of the 5 people surveyed, 2 like cricket, 2 like football, and 1 likes tennis. Then someone else says baseball, and then someone else says football. What do you notice? It gets a bit tedious and is not the best way to take a survey. Let's understand a better way to do this. Try to understand this really well. When the first guy says football, you just put a small vertical line next to football. No numbers, no order, nothing. The next guy says tennis. So we just put a vertical line next to tennis. Then the next guy says football. Again, we just draw a vertical line next to the first vertical line. Notice that in this case, we just don't have to think what the previous number was. We just draw a line when a person names his favorite sport. The next 2 guys say cricket. So we put 2 vertical lines next to cricket. And the list goes on. So until now, 2 people have said cricket, 4 people have said football, 2 people have said tennis, and 1 person likes some other sport. Now we come to the most crucial point of this exercise. When the next guy says football, as he will be the 5th person to say so, we strike out the first 4 vertical lines. So this symbolizes 5 people. But why a slanted line? Why can't we just draw vertical lines? Imagine counting the number of people if we did something like this. It will get really difficult, and that is why, as a norm, every 5th count will cross out the previous 4 counts. Let me erase this. So after asking all 30 people, this is how our final table will look like. These are called tally marks. We can write down the final numbers in the next column. The first row has 5 and 5. The number will be 5 plus 5, which equals 10. The second row has 5, 5 and 3. The total will be 5 plus 5 plus 3, which equals 13. So 10 people like cricket and 13 like football. In the same way, we can say that 2 people like tennis and 5 like other sports.
Question number 1 of this exercise says that blood groups of 30 students of class 8th are recorded as follows. So this is the given data. The next part of the question says that represent this data in the form of a frequency distribution table and find out which is the most common and which is the rarest blood group among these students. So we will be drawing a tabular column first and list out the various types of blood groups that we see here. So we have blood group A, we have blood group B, we have blood group AB, and we have blood group O. So we will be first finding the number of students who have got the blood group A. So the students with blood group A have been highlighted, and then there are 9 students that we can see. Then let's find out the number of students who have got the blood group B. So as we can see, there are 6 students who have got the blood group B. Our next step is to find the number of students who have got the blood group AB. So you can see that there are only 3 students who have got the blood group AB. Then we will be finding the number of students who have got the blood group O. So there are a total of 12 students who have got the blood group O. So now if we sum these numbers, we get a total of 30, which tells us that we have not missed on any of the student. From the given table now, it will be easy for us to find out that which is the rarest blood group and which is the most common blood group. So we can see that blood group AB is the rarest, whereas the blood group O is the most common blood group. So this is how we solve this question.
Question number 2 says that the distance in kilometers of 40 engineers from their residence to their place of work were found as follows. So these are the various distances of different engineers from their residence to their place of work. We have to construct a grouped frequency distribution table with class size 5 for the data given above, taking the first interval as 0 to 5 where 5 is not included. Then we have to tell what are the main features that we observe from the tabular representation. So to have a tabular representation, let's first have a tabular column. In here we have distance in kilometers, tally marks, and the number of engineers. So before we start representing this data in this tabular column, let's understand what all do we have which is given in this question. So we have been given with the distances of the engineers from their residence to their place of work. So we can take that as D, which is given in kilometers. The class size is 5, and they have given us that we have to start with a class which is 0 to 5. So the classes will go on like 0 to 5, 5 to 10, 10 to 15, 15 to 20, 20 to 25, 25 to 30, 30 to 35. Now we will have to see how many engineers do fall into these different class intervals that we have made. So in the first class interval, we can see that there are a total of 5 engineers. So we write the tally marks as 1, 2, 3, 4, 5, and we write the frequency as 5. Similarly, for the second class interval, there are a total of 11 engineers. So we write the tally marks as this, and we will also have to write the frequency, which is 11. Again, in the class interval 10 to 15, we have 11 engineers. So we again write the tally marks for them, and we write the frequency. In the class interval 15 to 20, there are a total of 9 engineers. So we write the tally marks and we also write the frequency for it. Similarly, for the rest of the 3 classes, we will be writing the engineers that are falling into that class interval, and we'll be writing their frequencies as well. So now if we add up the frequency, we get a total of 40. That tells us that we have not missed on any of the engineer. So from this, we can observe that there are 5 engineers for whom the distance D is less than 5 kilometers. That is, their office or the place of work is less than 5 kilometers from their place of residence. Now, there is a majority of engineers, that is a total of 36 engineers, for whom the distance D is less than 20 kilometers. And then finally, there are 4 engineers for whom the distance D is equal to or greater than 20 kilometers. So these are the main features that we observe from the tablet. Question number 3 says that the relative humidity in percentage of a certain city for a month of 30 days was as follows. So this is the data that we have. The first point asks us to construct a grouped frequency distribution table with classes 84 to 86, 86 to 88, and so on. The second point asks us which month or season do we think this data is about. The third point asks us what is the range of this data. So to answer these points better, we will first have to construct a grouped frequency distribution table. And as they have already given us that the class size is 2, because they have given us that the classes will be 84 to 86, 86 to 88 and so on. So we write that the class size for this data is 2. So we start writing the different classes. So we have the first class which is 84 to 86, then 86 to 88, 88 to 90, 90 to 92, 92 to 94, 94 to 96, 96 to 98, and finally 98 to 100. So now we will have to look into the given data and see how many days do fall under the different classes that we have made. So there are a total of one single day which is falling in the category of 84 to 86. Then again there is only a single day wherein we have the relative humidity within 86 to 88. So on we start filling for the rest of the class intervals, and so we get the frequency as for 88 to 90 to be 2, for class interval 90 to 92 as 2 again, for 92 to 94 we get 7, 94 to 96 we get it as 6, and for 96 to 98 we get it as 7, and finally for the class interval 98 to 100 we get it as 4. Now if we sum up the frequency, that is the number of days, we get a total of 40. So that tells us that we have not missed on any of the days. Now the observations that we make from this is that the relative humidity was 92% and above, and for a period of 24 days of the month. Since the relative humidity percentage is very high, it must be a data from a month of rainy season. So the answer for the second point is rainy season. Now the third point asks us to find the range of this data. Now range can be found by having a maximum value and then subtracting the minimum value from it. So the maximum value and the minimum value are to be taken from the given data that we have. The maximum value that we have, that is the maximum relative humidity in the given data, is 99.2, and the minimum is 84.9. So we subtract 84.9 from 99.2 and we get the range as 14.3. So this is the range of the given data. Question number 4 says that the heights of 50 students measured to the nearest centimeters have been found to be as follows. So this is the given data to us about the heights of 50 students. We have to represent the data given above by a grouped frequency distribution table, taking the class intervals as 160 to 165, 165 to 170 and so on. And then it says what can you conclude about their heights from the table. So let's first have a table when we have height in centimeters and the number of students, that is the frequency associated with a particular class. So as already given in the question that we will have class intervals as 160 to 165, we get a class size of 5. We start with 150 because 150 is the lowest value that we see in the given data. So our class starts from 150 to 155, 155 to 160, 160 to 165, 165 to 170, and then finally 170 to 175. Now we will have to see how many students do fall in each of the class intervals. So we can say that height in centimeters is h. Now let's see the number of students that fall into each of these classes. In the first class, that is from 150 to 155 centimeters, we have 12 students. In the second class, 9 students. In the third class, 14 students. In the class interval 165 to 170, we have 10 students. And finally, in the last class, that is 170 to 175 centimeters, we have 5 students. So this, if we add up, that is, if we do the sum of all the frequencies, we get a total of 50, which is the number of students that we have. Now, the features or the conclusions that can be drawn out of this table are that a majority of 70%, which means 35 students, have their heights less than 165 centimeters. So this is one of the conclusions that we can make. The second conclusion can be that 10% of the students, that is 5 students, have their heights equal to or greater than 170 centimeters. So this is how we solve this question. Question number 5 says that a study was conducted to find out the concentration of sulfur dioxide in the air in parts per million ppm of a certain city. The data obtained for 30 days is as follows. We have to make a grouped frequency distribution table for this data with class intervals as 0.00 to 0.04, 0.04 to 0.08 and so on. And then we have to find for how many days was the concentration of sulfur dioxide more than 0.11 parts per million. We will draw first a grouped frequency distribution table. So we start with the class intervals as 0.00 to 0.04 as given in the question, and with a class size of 0.04 we construct the other classes as well. Now that we have constructed the various classes, let's find the frequencies associated with each of the class. So for the first class we get the frequency as 4, for the next one 9, for the next one 9 again, for the next one 2, then 4 and then 2. Now if we sum up all of these frequencies we get a total of 30, and that is the number of days for which the study was conducted. From this table, we can see that the number of days during which the concentration of sulfur dioxide is more than 0.11 parts per million falls over 3 class intervals. And those class intervals are 0.12 to 0.16, 0.16 to 0.20, 0.20 to 0.24. So if we add up the frequency of these 3 class intervals, that is 2 plus 4 plus 2, which equals 8, we can say that for 8 days we had a concentration of sulfur dioxide which was more than 0.11 parts per million. So the answer for the second bullet point would be 8 days. And this is how we solve this question. Question number 6 says that 3 coins were tossed 30 times simultaneously. Each time the number of heads occurring was noted. So this is the data that we have about the number of heads occurring. We have to prepare a frequency distribution table for the data given above. So we make a table wherein we have number of heads, tally marks and the frequency of occurrence. So we can have different possibilities as seen from the data which is given to us, that head may not occur at all, that is 0 times. Head may occur once, that is 1 time. It may occur 2 times, so 2. Or it may occur in all the 3 coins, so it can be 3. So now let's see what is the frequency associated with the different cases that we have. So for 0, the frequency is 6, so we write tally marks as 6. And the frequency is 6. For 1, that is the head occurred only in one of the coins, is 10, so we write the tally marks as 10, and so for the frequency that is 10. Head occurred 2 times, 9 number of times, so we write the tally marks as 9, and so the frequency is 9. And finally we have head occurring in all the 3 coins 5 times, so the tally marks is 5 and the frequency is also 5. So if we sum this up, that is the frequency of occurrence, we get a total of 30. So that tells us that we have not missed on any of the data point, And this is how we prepare a frequency distribution table for the data which was given to us. Question number 7 says that the value of pi up to 50 decimals places is given below. So this is the value of pi up to 50 decimal places. We have to make a frequency distribution of the digits from 0 to 9 after the decimal point. And then we have to find what are the most and the least frequently occurring digits. So we will first have to make a frequency distribution table of the digits 0 to 9. So this is the table that we make, and the digits are already listed. We will have to find how many times are these digits occurring. So for 0, it's occurring 2 times, so we write the tally marks and the frequency. 1 is occurring 5 times, and its frequency is 5. 2 is occurring 5 times again, so the frequency for it will be 5. For 3, it's 8. So the frequency will be written as 8. For 4, the frequency is 4. So we write the tally marks and the frequency as 4. For digit 5, the frequency is 5. So we write the tally marks and the frequency as 5. For digit 6, it's occurring 4 times. So the frequency and the tally marks are written as 4. Digit 7 is occurring 4 times. So its frequency is 4. Digit 8 is occurring 5 times. So we write its tally mark and its frequency as 5. And finally, digit 9 is occurring 8 times. So we write its tally marks and its frequency as 8. Now, it can be easily observed from the table that the most frequently occurring digits are digit 3 and digit 9 with a maximum frequency of 8. And it can also be easily observed that the least occurring digit, that is the digit with the least frequency, is 0 because its frequency is the minimum, that is 2. So this is how we solve this question.
Thank you for watching our channel. இந்த வீடியோ உங்களுக்கு பிடிச்சிருந்ததுன்னா கமெண்ட் பண்ணுங்க, லைக் பண்ணுங்க, ஷேர் பண்ணுங்க. மறக்காம இந்த சேனலை